Our next topic is from Nethermind. It's about Nethermind client and optimizing Nethermind's sync time. All right, our speaker is Ashraf. We're going to welcome him to the stage. Ashraf, where are you? Can you wave your hand at me? Oh, there he is. Let's give Ashraf a big round of applause. All right, he's going to be speaking about Nethermind. You give slides this now, right? Okay, I'll get the slides ready. Just get your slides ready. This is about the Nethermind client. This is our second last session for this evening. After Nethermind, we've got a consensus layer on Ethereum. Okay, let's see. This one, right? Yeah, there we go. Okay, your microphone is over there in the clicker. You can just test it out. Okay, our second last session for this evening, all the way from Nethermind. Ashraf, the stage is yours. Take it away.
Hello. All right, it's working. It is working. Okay. Assalamualaikum. Hello. My name is Ashraf. I work for Nethermind as a core dev team. So I'm an Ethereum core dev, meaning that I work on the Ethereum client for Nethermind. So what is Nethermind? So Nethermind is the second most popular Ethereum client. So everyone knows about Gas. Gas is this guy over here, which is the most popular one, and right behind it is Nethermind. And according to Ethernodes, it's around 30% market share. I think it's on Monday or something. This is Ethernode. Ethernode is not very accurate. There's some, something about it that people talk about. But yeah, next is Nethermind, roughly. So why is it important? It's important because of client diversity. It's important for client diversity. You know, Ethereum have a lot of client, different type, and there's Aragon, there's Gas, there's Rest, and everything else. And then there's also Nethermind. So why do people use Nethermind? From what I heard, is because of its sync time, which is faster than Gas, and also because apparently, if you look at Reddit, it's because of the attestation performance, which is usually higher than other clients. That's why people switch to it. So I'm here to talk about the sync time because a lot of the time I work on it, right? So I work on it. I used to work on the merge, and then after that, usually bug fix and also the sync time, right? So there's a lot of optimization at the sync times. So sync time is important because it makes it easier to switch client, right? If you try to switch to Gas, at least for me, it will take around 6 hours to sync. But for Nethermind, it will take around 3 hours. Which is half of the time. And there's a lot of reason for that, but it's largely because of engineering decision, in my opinion. Gas focus a lot more on efficiency, and Nethermind focus a lot on throughput, meaning that if you still have some SSD bandwidth, it will use all of it as much as it can. And sync time is important because of many reasons. Aside from the easy barrier of entry, a slow sync is also essentially a hanging sync, meaning that because the chain is keep moving, if the sync is too slow, it will need to do more work in order to catch up with the network. So you need to have it to be reasonably fast. And also it's because it makes it inspiring confidence because Nethermind have a 95% sync rate. The definition of sync here is a bit, it depends on how Ethernodes interpret it, and it also make development easier for me because I don't have to wait 6 hours, so I just have to wait 3 hours or something like that every time I need to change the database configuration or something. So if you look at the sync rate over here, Nethermind is, that the statistic for the one that is sync, Nethermind is actually really close to Gas, like 38%, and Gas is 39%. So last week that's like minute of time when Nethermind have a higher percentage than Gas according to these metrics. So it is pretty close there. This is more statistics. So we have Nethermind at the highest sync rate. The definition of sync is a bit blurry. And that's Gas at around 60% and the rest. So this is a graph of the sync percentage and also the Nethermind's market share, which is around the blue and the yellow line. As you can see, around the merge, the sync percentage goes up to around 95%, and the market share also goes up. Last week, there's like a big jump in there. So we are at around 35%. It's actually go down a bit. So actually, when it actually goes up, what happens is like gas goes down a lot. Like there's 100 or so gas node that goes down, and when it goes down over here, there's like 100 or so gas node that actually goes up. So the percentage is not, it's a bit flaky because of gas. This is in terms of the absolute number. So as you can see, Nethermind is still going up. I don't know until when. I thought there would be like a little stop over here around 30%. But then again, last week it goes back up. So I don't know, you guys are still switching to Nethermind. So pardon the impeccable handwriting. So this is how, sorry, let me just, there we go, much easier. I'll just stand over here. Right, so this is roughly how Nethermind sync. And this will explain what does it mean by sync rate over there. So actually, Nethermind does not sync from Genesis. It sync from a block that is close to the head. We call this a sync pivot. And from there, once it's sync close enough, it can start snap sync. So snap sync, and after that, there's a snap healing, because snap sync, which is downloading the trie that is required for the block processing, actually doesn't download the trie completely. So there need to be a small phase called snap healing. And this whole phase, after this, Nethermind can process block. So at this point, Nethermind is essentially following the head. It can return the new payload message correctly to the consensus layer. However, it has not downloaded all of the blocks and the receipt yet, and that will take another two hours. And another difference from Gas is that Nethermind doesn't actually download all of the blocks and receipt. It only downloads it to something called the ancient barrier, which is around block 12 million or something, roughly that. So which is the block that is starting required for the consensus layer to work correctly. So the whole process takes around 3 hours if you have a setup similar to mine. And this first phase before the start of the process block will take around 80 gigabyte of bandwidth, and the rest will take around 500 gigabytes of bandwidth. So so there's a lot of improvement over the years on each of these phase. The first phase, which is the fasting, which is the traditional fasting, but we don't actually start from Genesis. The sync pivot used to be configured inside the sync config, and recently it was changed so that the sync pivot will be get from the consensus layer. The consensus layer will call Nethermind periodically for what it thinks is the best, what it thinks is the canonical block and the finalized block and such. So it used to be configured manually within the sync config file. So what happened is usually is that people will notice that older Nethermind version take longer time to sync. That's because the configured trusted pivot is actually older. So it needs to take more time before it can start snap sync. Nowadays, it's no longer an issue because we just take it from the consensus layer, and it will only need to download around 60 block or something. So it will take like 1 minute to complete it. Assuming that the consensus layer already sync, which is depending on how it is synced. Something usually is a checkpoint sync, so it's like, I don't know, exactly 1 minute or so. And after that, we have the snap sync phase, and there's a lot of optimization done on this part, because this part is the most processing heavy part of the sync process. So the two most, I guess, important part before is on this part, which is a 5342. And what happened before, a few versions before, is that Nethermind still have bandwidth, still have processing power, but it doesn't know what to do exactly because it's blocked by a certain request which is not parallelized. So this change just parallelized that and just split the top level address range into 8. And this cut down the sync time from roughly around, how much is this, 45 minutes or something, down to 35 minutes or something like that. Right. Another big improvement is that a sync DB tuner, which is nowadays enabled by default on 1.21. So what happened is that during syncing, Nethermind will change the database configuration a bit so that it will be write optimized. It sacrificed a bit on the read performance, but because SnapSync is very largely just writes and very little reads, this reduced the overall sync times quite dramatically. So the overall bytes written is around 30 to 40% reduced, and this cut down the rate of the writes from roughly, how much is this? 60,000 K, 600K nodes or something to roughly 1.5 million nodes or something. So it really depends on the SSD and the processing power, right? In this case, it's about 30 minutes, slightly less than 30 minutes for the SnapSyncs. Yeah. So SnapSync so it's very close. So this is what happened. This is probably what Ethereum counts as sync, right? So that's why the sync percentage of Nethermind is quite high, because it only takes around 40 minutes or so for this particular phase to complete. And at that point, Nethermind will return a status code that's saying that, yeah, our latest block is definitely close to it, because we are processing the block and such. We just don't have the rest of the blocks to respond to RPC. Another thing is that concurrent read and write during state healing after the SnapSync, because SnapSync doesn't produce a correct try, so it cannot really process the block, right? So previously, it turns out that the read and writes for this particular phase is behind a single lock, so it cannot be parallelized. And if you try to benchmark SSD before with a single thread, the maximum IOP is around 12.5K IOPS. So it's not like 1 million IOPS that the manufacturer usually advertise, right? So this changes that to use a read-write lock, and it can paralyze the read by quite a lot. And after this phase goes down from around 50 minutes to 2 minutes, typically on a fast SSD. And this particular phase is quite important, because if your SSD is slow enough, essentially you cannot sync, because it will have to do more work if it's slow, right? If it goes too long, then it will need to find another try and restart the whole process. So that's why if you go to the support page of Nethermind, some people finish this in around 15 minutes, another people take overnight to resolve this, because of it needs to catch up to the network, right? So this changes that, so that it's no longer become a bottleneck. And then we go to the next part, which is a fast block. And this is also another recent change enabled by default on 1.21 also. And previously, the process of downloading the blocks take a huge amount of write bandwidth of the SSD. This is largely because of database compaction. Because of how RocksDB works, there needs to be some kind of compaction happening. And this changed that by basically just enabling a feature of RocksDB called blobsdb. And this cut down the total writes by about 5 times. So that's why you see inside the release note of the latest version, there's saying that in some configuration, it reduces the sync time by about 5 times. It depends if you are limited on the SSD or not. In my case, I'm not very limited on SSD, so it doesn't change that much in my case. And another difference is the fast receipt, which is done before the previous changes. That's why you see it doesn't consume much bandwidth over here, even though that the database of receipt is actually quite large. It's probably around 100 gig compared to blocks, which is 300 gig. Right. So the changes is actually quite simple, which is just to prefix the key, the RocksDB key, with the block number. So this trick, which if you look at the database design of Aragon, which Aragon does for every database of it, actually reduces the compaction by quite a lot. So this reduces the bandwidth, the total writes for the receiptsDB phase by about twice or something. But this particular phase usually is limited by the CPU, so it probably doesn't make much of a difference for most people. And yeah, I guess that's it. That's all in my presentation. So what's next for Nethermind? That's Cancun and all of the protocol level stuff. There's also a flat DB layout, still working on it. I'm not sure. It's a very problematic system. And there's some other things that I'm thinking of doing. Yeah. So that's it.
All right. Thank you, Ashraf. Speaking about the Nethermind client and the upgrades and all that, anybody got a question about Nethermind? We got one here. We'll pass the mic to you. It's just coming in a minute. Please introduce your name and your question.
Hello, I'm Wei Han. So I wanted to ask regarding the snap healing process. So my understanding is that because it's trying to keep up to the network, that's why you have to do some healing on the outdated try nodes in the try. So what happens if, let's say, a small or a big reorgs happens in this case? Would it affect, if my understanding is correct?
The main point isn't really to catch up with the network. The main point is that after the snap sync, the try is not correct because different part of the try comes from a different block. So it needs to finish it. And state sync, the head must be from a canonical block. So it picks a try from the canonical block. That's how it prevents that issue.
Okay, I think I also have my second question, which is on, let's say if we were to compare Geth and Nethermind. So for my understanding from the very nice handwriting that you had,
Impeccable handwriting.
that basically Nethermind, it feels like the architecture's philosophy is that, let's say for Geth, is, if I remember correctly, for SnapSync, it will download all the blocks, download all the data that is not needed to process blocks. But for Nethermind, is that, okay, what do I need to process a block, which is just the tries, the updated state, right? So once you have the complete state, then only you download all the so-called unnecessary things that needs to so-called keep up with the network or to continue with the network. So is that, is my understanding correct in that sense?
Yeah. More or less.
Okay.
Yeah, that's
Really
that's
straight
a
to the
lot.
point answer. Yes.
There's quite a lot more different than that. For example, Nethermind doesn't download all block, right? So it download from the ancient barrier, which is block 12 million or something. So if you want something further, you have to change the configuration so that it downloads that also. Another difference is that GAS has an what we call that ancient database, right? And the restriction of the ancient database is that you must insert the blocks in a strictly increasing order, right? And the problem with that is that you have to reorder the block somewhere in the memory or something, right? So that's a sacrifice they have to make. And if the memory buffer is slow, they have to throttle it down, right? So Nethermind doesn't do that. Nethermind just dump the whole thing to the Roxby and let Roxby do whatever it needs to do. That's different.
Okay. If anyone doesn't have any question.
Are there any questions? No, it's all yours. Go ahead.
Okay. Geth also has they recently upgraded to PebbleDB. So is there any plan? I mean, do you think it makes sense for Nethermind to upgrade to PebbleDB in the future?
If there's a binding, it might make sense. So it makes a lot of sense for Gas to upgrade to PebbleDB mainly because LevelDB previously doesn't have a concurrent compaction, and that really limits their write rate. So that's another reason why Gas might be slower. But another different reason is that PebbleDB is kind of like RocksDB++. You kind of can make RocksDB as fast as PebbleDB, but you have to tune it quite a lot, and until a certain point where you don't really have a choice but to switch to PebbleDB. But that point is quite high. So does it make much sense for us to make a C# binding for PebbleDB to, have a write limits higher than 1.5 million keys per second? It doesn't make much sense if you ask me.
Okay, understand. I think my last question here is not technical related. Just want to understand more about yourself. Is that because I previously talked to you before, but what's the difference between building a distributed system in blockchain space versus, like, let's say in the traditional Web2 space? Yeah.
I think the main difference is that with distributed system like this, you have to validate every message. You have to validate every single message in one way or another. In a distributed system, in a big tag, you don't have to do that. And this actually add quite a lot of overhead. For example, in my development setup, I have 4 Gas nodes running locally. Takes up 70 gig of RAM. so that I could saturate Nethermind. And why is it 4 gas nodes instead of 1? Because a single connection have a limit to how much bandwidth it can because of the RLPX decoding. Because we need to encrypt the connection. So now there's a limit over there. So that's probably the biggest difference in terms of networking.
Okay, any other questions? Feel free to raise your hand if you want to ask about the Nethermind client, or any of the upgrades, going once, going twice. All right, let's give our speaker a round of applause. Thank you very much, Mr. Ashraf.